Hello, it's Ruby. I'm going to be going over how to pick a dilution, how I personally pick dilutions for ELISAs, how to calculate out my dilutions. There are many ways to do it, but I'm going to show you work out the math, how I do it, and then at the end, kind of diverging a bit from ELISAs, still working with dilutions, how to do a really dilute concentration for something like a BCA assay. So when you first get your kit, you will see the paper protocol included. It'll talk about running a test to make sure that you know the dilution to use for your samples. I also take this as an opportunity to make sure that the standards are working, just because we've had issue in the past. It would be a shame to run a full kit and not do a test, only to find out that your standards did not work. So one strip will be used entirely for my standards, 1 through 8, where 1 is the most concentrated, usually in nanograms per milliliter. It ranges based on the kit. The OD value will typically be around 2.4, but not always. And 8 is usually your 0 concentrated standard, and the OD value will be like 0.06. As long as your samples read within this range, you're totally fine to do a full run with whatever dilution gave you that. But it's important to balance how much sample you're using, the OD value, where it lies within the range of your standards, just to make sure that everything fits in and you're being as conservative as you can be with your samples. So let's say in this example I have both the cortex and the hippocampus to run. If you ever are curious how ELISAs have been ran in the past in the lab, you can take a look at the Excel sheet in box. It has all the information that you'd ever want to know about the ELISAs. But typically for the cortex, a 1 to 50 or around a 1 to 50 is a good dilution to aim for. And for the hippocampus, a 1 to 10 is a good dilution to aim for. However, just because we have these dilutions that have worked in the past doesn't mean that we're just going to roll with it. I like to test out some dilutions both below and above my target that I'm aiming for. So for the cortex, that ranges from a 1 to 10 to a 1 to 100, and for the hippocampus, that ranges from a 1 to 4, usually to a 1 to 20. So I have my 8 wells set. I've already aliquoted them out to be used for this. I've calculated that out into how many samples I'm going to run, how many I need to leave over for test dilutions. I have 8 dilutions that I want to test out here. So mentally, I'll make a note that the top half will be for the cortex and the bottom half will be for the hippocampus. I will pick 2 samples and I'll have them be like 1 and 3 and 2 and 4. And the reason why I do that is so I don't use too much of the same sample for all of my dilutions. So I'll do like a 1 to 10, which will take the most amount of pure sample in this 1 to cortex dilution test. And then I'll split that over the 1 to 20, 1 to 50, 1 to 100. And I'll do the exact same thing for my hippocampus, whatever my dilutions are, and I'll split them across, just so I'm not using too much of one sample. We want to have enough to run the full kit with. My goal OD value typically lies around the 5 and 6 standard, 5th and 6th standard, and that value is usually anywhere between 0.3 to 0.5. That is what I feel comfortable running a full kit in. But again, if your samples are being finicky, as long as you're within that range, that 2.4 to 0.06 range, or whatever your standards read at, you are fine. Just make sure that your samples are within the range. So for the purpose of this, let's say that for our cortex, the dilution that worked out well, that gave us a nice OD value, was our 1 to 20. And let's say for the hippocampus, that was a 1 to 5. In the protocol, it'll tell you how much of your sample it wants in each well. And in my experience, that has always been 100 microliters, but make sure you're checking how much total you will be pipetting into the well. So we know how much total volume we need, and we have our dilution here. We have to figure out what factor of 100 goes with 20. An easy way to do this, if you can't do quick math in your head, is you just take your total and divide it by your dilution to get your factor. And then you multiply straight across once you have your factor, and you'll see that you have 5 microliters of your sample with 100 microliters total. But it is very important to note that you will not be pipetting 5 microliters of your sample into 100 microliters of your dilution, or of your diluent. You will need to make sure that your numerator and denominator add up to be your total amount pipette volume. So you just subtract them out, and you get 5 microliters of your sample with 95 microliters of your diluent. The kit comes with a diluent, but you can also use PBS. So this is what you will be pipetting. And you'll be using your little aliquot of your tissue homogenate. This is that. That's what you'll be pipetting from. So the same thing for the 1 to 5. It'll be easy because we already have the math there. We know that it's a factor of 20. So multiplying across, we get 20 microliters of our sample, but this instead will go into 80 microliters of our diluent. And again, that's from your aliquot, the 20 microliter sample. So, as long as your dilution, you'll want to do dilutions for all of these that you've picked up before, I guess these over here. You want to do dilutions out just to see what works the best, what lies within the range at a comfortable position. So now we'll be talking about further diluting if you need to get something to a 1 to 300. So for a BCA analysis, I'll usually go from like a 1 to 100, 1 to 200, 1 to 300, 1 to 400 for my test dilutions to see what will be a comfortable OD value. It's the same principle. Why can't we just do a straight 1 to 300 dilution? Well, when we work out the math, we have a 1 to 300 dilution for your BCA assay. It's 150 microliters total that you'll be pipetting of your sample. So doing the math and figuring out the factor here, it's 0.5. I think we have a pipette that can pipette that much, that small, but it's not ideal. And if we don't have to do it let's not. So I've been told in the past that any higher dilutions start with a 1 to 20. So that's what we're going to do. We're going to start with a 1 to 20 dilution, and let's make 100 microliters of this 120 dilution. We've already done the math. The factor of 100, that goes with 20. It's 5. So we have 5 microliters of our sample, and that was this up here. 5 microliters of that. It's kind of in my way, actually. Will give us 5 microliters of our sample into 95 microliters of PBS, 1x PBS. So this is our 1 to 20. We have 100 microliters of 1 to 20. Well, we need to then dilute 1 to 20 to 1 to 300. It's the same principle here. What factor of 300 goes with 20? This time it's 15. The difference here is we will take that 15 and have that be a dilution. So we're diluting our 1 to 20 by 1 to 15. And following the same rules as above, we have 150 microliters of sample that will go into our well of a BCA assay. We need to find the factor here. This one's easy. It's 10. 10 microliters of our 1 to 20 sample, and 150 microliters total. So we will be pipetting 10 microliters of 1 to 20 into 140 microliters of PBS. So you'll have, when you make your 1 to 20, I'm going to make this one purple just so it's different. Your 1 to 20 will start from 5 microliters of that, but then your 1 to 20 will be here. This is like aliquot A, maybe. I letter mine A through B, or A through C, and then this is your 1 to 20. So hopefully that all makes sense, and that'll be helpful in the future when you need to do a dilution for an ELISA or for a BCA assay, and how to figure out which dilution to use. As long as you're within the range, totally fine. If you can be at a comfortable middle, even better.